Now, factorising by the highest common factor is the complete opposite process of what we actually did when we're expanding brackets using the distributive law. And the distributive law said that if I had A bracket B plus C, to expand this is the equivalent to that A value multiplying each term inside the brackets. So in this case, the A multiplied by the B, add the A multiplied by the C. Now the equation that remains here is equal to each other, but each side of the expression is in two different forms. We call this form here expanded form. And on the left-hand side here, we actually refer to this as factorized form. Now, when we're using the distributive law and moving from here to here, we call that process expanding the brackets. But today we're going to focus on the complete reverse, how we go from the expanded form back to the factorized form. And we do what's called factorizing by the highest common factor to achieve this. Now, to do this process, we actually need to know what a highest common factor is, or what we refer to as common factors in general. So to be able to move from expanded form to factorized form, we first have to know what is referred to as the highest common factor. So let's consider the following. What if I had 2a plus 4? What we want to do here is we want to have a look at each individual term that we've got here and see whether, first of all, there is a number that we can divide each term by, which we refer to as a factor. In this situation, I can easily see that both our terms here divide by the number 2. So we can say that we've got a highest common factor of 2. And what we do with this highest common factor is we put it down at the front, and we now divide each individual term that we have here by the highest common factor. So if we were to divide 2a by 2, we would just be left with a. And if we were to divide positive 4 by 2, we would be just left with positive 2. And what we've now achieved is we've moved from the expanded form, which was up in here, to now the factorized form, which we've got here. And the advantage with all these is we can always check to make sure that we're right by using the distributive law. So let's do what I call a check step. So to check this, currently we've got 2 bracket a plus 2. When we multiply this out, there's going to be 2 times a, which is 2a, and then 2 times positive 2, which is positive 4, which is what we had when we began. So it means that we've factorized this correctly. So this works if we've got a common factor that's a number. Now, common factors aren't always just numbers. Like, I want you to consider this one. What if I had x squared plus x? Well, in this case, the coefficient of both terms here is 1, but we're not going to be dividing that by 1. But what we can see is common between both of these is the value of x. So what we can do here is we can say we've got a highest common factor of x. And we can follow the same process by putting the x at the front, opening up a bracket, and dividing each individual term by our highest common factor. So x squared divided by x will leave us with x. And then x divided by itself will be 1. So it'll be x plus 1. And as with before, we can check to see whether we've got this right. So in our check, we have x bracket x plus 1. When we multiply this out, we've got x times x, which will be x squared, and then x times 1, which will be just plus x. And we've arrived to the statement or the expression that we had to begin with. So we've factorized this correctly. Now what you can see here is common factors can be both numbers, but they can also be variables. So we've got to look at each individual term that we've got in our expression to see whether there's something that's common within each term that we can factorize out. But there is one more that I want to take a look at. What if I had 3x to the power of 4 plus 6x to the power of 3 subtract 9x to the power of 2. Here, I've now got 3 terms in my expression. So what that means is when I'm looking for a highest common factor, I'm looking for something that is common to all 3 terms. So I can factorise all 3 terms here. Now to do this, because there's both numbers and variables that we can factor by, we have to look at each individually. So each term individually has a common factor of 3. So I can already record this down. But when I look at the variables, I can see that each one of these variables has a variable of x. But what I also notice here is it's actually got at least an x to the power of 2. Each one of these terms is x to the power of 2 or higher. So our highest common factor here is actually 3x raised to the power of 2. So when I'm factorising this common factor out, I need to divide each term by 3x to the power of 2. So as I do that, I put my highest common factor at the front, I open up a bracket, and I look at the first term here. If I was going to do 3x to the power of 4 divided by 3x to the power of 2, well 3 divided by 3 will be 1, so I don't need to record anything. But x to the power of 4 divided by x to the power of 2 will leave us with x to the power of 2, because we keep the base the same and we subtract the exponents. In our second term, we've got 6x to the power of 3. When we divide that by 3x to the power of 2, 6 divided by 3 will be 2, and because it's positive and positive, we'll be adding. Then x to the power of 3 divided by x to the power of 2, keep the base the same, subtract the exponents. So we'll be left with 2x, or 2x to the power of 1. And our last one, we've got negative 9x to the power of 2 divided by positive 3x to the power of 2. Now negative divided by positive will be a negative. 9 divided by 3 will be 3. And then x squared divided by itself will cancel out to equal 1. So it'll be 3 multiplied by 1, which is just 3. So what you can see here is I've now taken the common factor of 3x squared out of the expression that I had. But I can check to make sure I haven't made any mistakes here. So if I had 3x squared, opening up a bracket, x squared plus 2x, take 3. What I can do here is use the distributive law and multiply this out. So 3x squared times x squared will be 3x, and we're adding the powers this time, so 3x to the power of 4. 3x squared times 2x will be 3 times 2, which is 6. Then x squared times x, which is x cubed. Then we've got 3x squared multiplied by negative x will be a negative. 3 times 3 is 9. And then x squared. So what you can see here is my check steps showed me that I've factorised this expression correctly. So in summary, expanded form is when we use the distributive law to remove things from their brackets. Where factorised form is where we're putting it back in the brackets essentially. And one way that we can do this is to look for any highest common factor that exists. Now, the distributive law and factorising by the highest common factor are essentially opposite processes. And to be able to factorise by the highest common factor, we need to be aware that we have to look for both a number that's common with each term that we're trying to factorise, but also a variable component that might be common within each term that we're factorising.